So a few housekeeping items. If you have Discord on your phone and you're on the Star Trek channel, there is a SQL versus NoSQL chat that you can send questions to if you have any questions. And I'll be monitoring that channel. Welcome. And welcome to my talk. So this is Stop Fearing Databases, SQL versus NoSQL, Navigating the Database Dilemma. My name is Henry Saint-Juste, but if you're a French speaker, you would pronounce it as Henri Berson Saint-Juste. So I'm a solutions architect at NetJets. I joined NetJets about 4 years ago now. Primarily, my background is in native mobile development. I got my start in game development using Objective-C and Swift to build games for the iOS platform. And then I dabbled into mono development with C#, as well as native iOS game and other applications for the App Store. I'm a developer at heart. So, you know, I love building tools. I always think about the developer journey and the pit of success. So I'm always building different tools, developer tools, like command line interfaces to help the engineering journey just become a little bit more faster. I call it speed of thought. And at NetJets, I support the owner portal's mobile app and web application, as well as front-end technology at NetJets. So, what are databases? What are they all about? In this talk, we're going to be covering the different trade-offs, the challenges, and the best practices for building a scalable database system using either SQL or NoSQL. But databases, essentially, they are a way of storing information, either in memory or on an actual device, right, on a hard disk. In-memory databases typically are like a Redis cache or Elastic cache if you're using AWS. And then you have your traditional other databases like your Oracles and so on and so forth. And typically, to be able to access a database, you have to use a database management system or a DBMS. Essentially, what you use that for is to interact with the database to create information, to create data, to read the data, to update and mutate the data, as well as to delete that data. So this is the typical workflow of how you interact with a database management system. Basically, you have your client, and then you have your graphical user interface. And from your client, right here, you're interacting with the database management system, and that's interacting with the database itself. And typically, you have a connection string, a username and password to be able to make that connection. So let's look at the different types of databases. You have SQL, which stands for Structured Query Language. And you have different flavors. You have Oracle. You have Microsoft SQL Server. You have MySQL and Postgres. On the other end, you have NoSQL databases. Those are your MongoDBs and AWS DynamoDB. Typically, they are in collections and documents, and SQL is, you know, typically in tables, or always in tables. So, SQL or SQL. SQL was created in IBM in the early 1970s, specifically 1974. And when it got created, originally the name was SQL, like that spelling. But because of a trademark issue or conflict with an aircraft company that had the same name, they had to rename it to just SQL. So what are the different trade-offs? With a SQL database, typically it's relational, right? You have tables, and those tables have primary keys, and you have other tables that it relates to, which you would have the foreign keys in those tables. And also, when you need to scale your database, it's usually vertical scaling, right? So you have to add more memory, more IOPS, more input streams and output streams to be able to access your database. And then it's table-based, and you're using the structured query language to be able to access and interact with that database. With NoSQL, usually it's non-relational. You have collections and you have documents, and then also you have horizontal scaling. So you can add different databases horizontally. And then it's dynamic in nature. You have unstructured JSON into your NoSQL database. So designing databases. Usually there's this flow when you're designing the database. You have your conceptual model, your logical model, and your physical model. Typically, you start at the conceptual model, and this is where you're gathering requirements. And this, I like to call this the database design lifecycle, similar to the software development lifecycle. It is an iteration, so you're always looking at different ways you can improve your database, and you're not locked to that structure just because you can also create a database script where you create your migrations for your database. But number one, you have to understand the requirements. That's the most important thing. You get with your business stakeholders, you talk to them and understand what kind of structure your database need to have, and think about the size of that data and how you can structure that data. Then you go and you build a conceptual model. This is a visual representation of what the database will look like, interactions, and then you build a logical model. And all these are independent of a database management system. Then when you actually build a physical model, this is when you actually have to select a database management system. So the conceptual model that we're going to build or go through now is CourseWorks. So we're going to be building a platform that sells online tickets or online courses where students can enroll in one or more courses. And we're going to represent the entities and their relationship, and then we're going to use unified modeling language. We could use unified modeling languages, and the tools to be able to use to have that conceptual model, you can use Microsoft Visio, you can use Draw.io, you can use Lucidcharts, StarUML, or Miro. For this exercise, we're going to use Draw.io. All right, let's jump into the hands-on exercise. Give me 1 second. Let's see. Awesome, cool. All right, so let's look at the conceptual model. So we're building CourseWorks, and let me zoom in. Can everybody see? Awesome. So we have a student. Whoops. Boom. We have a student, and that student has a name, an email, and the time they registered for the platform CourseWorks. And then we have a course that they can enroll in, which has a title, a price, an instructor, and some tags. And the way we represent this relationship would be a student can enroll in many courses. Now, looking at this right now, this is just a conceptual model, but typically you would introduce like a link or pivot table in between student and courses. But for the conceptual model, this is what it is right now. And we don't have any type-specific annotations. Like, we're not saying, okay, name is a string, or email is, a string that follows this particular pattern or regular expression. We're not saying date is a date time. and we're not given any like decimal annotations to price. So this is just a way to communicate with your stakeholders in a way that they can understand. Awesome. The next step is your logical model. So with the logical model, this is when you start introducing your link tables or your pivot tables. This is when you also look at normalizing your data, right? Looking at which information can be in this table and which information needs to be segregated out to another table. And typically when you do this, you usually, there is a method to this. It's called the seven rules of normalizations. So you have the first normal form, the second normal form, and the third normal form. And we're going to go through that right now to understand what that is. And then you look at to optimize your database as well. So let's look at an example of the logical model. All right, so with your logical model, now you start introducing some of these annotations. So first name is a string, so on and so forth, and then date registered will be a date time object. And then now you can see we don't have that enrollment going straight to courses. Now we introduce what is called a pivot table. And then in course, we start introducing price as a float. And then with this pivot table of enrollment, we have a date. This date represents the date the student would enroll in this course. And this price represents the price at the time when the student purchased this course. Because at the time, the course may be, let's say, $50. But at the time when they enroll, there was a promotion. There was probably like a buy one, get one off, some sort of deal. So at that time, the enrollment, this is the price that gets captured because this price would fluctuate based on what promotions that platform is running at that time. And this is a one-to-many relationship. And on the other end, we have another one-to-many relationship. And this is why we have a many-to-many relationship with the students in the course. So a student enrolls in many courses, and a course can have many students. Any questions so far? Awesome. And then you have designing databases with physical models. This is the time where you would enrich your attributes, where you actually add actual data types. Instead of string, you would use varchar, which is specific to that database management system. You would introduce your primary keys, and you would introduce your composite primary key. So a primary key and a composite primary key is using the primary key and the foreign key together to create that. And then you would introduce or set your foreign key constraints. And then this is when you actually would use a tool specific to that database, either MySQL Workbench, AWS NoSQL Workbench, or MongoDB Atlas to be able to build out your physical models. All right, so let's jump into the physical model. So for this, we're going to be using, NoSQL Workbench. Oh, geez, it's hard to see. Can you all see properly or no? Looks better? Okay, cool, awesome. So let's go ahead and do this. So we do File, New Model. EER stands for Enhanced Entity Relationship. And we are going to double click on add diagram. And then this icon here is to actually create a table. So we're going to click this, add this here. Oops, cancel. Okay, now that we have the table, we can name the table. And this is going to be first students. Okay, we have our students. And typically when you create your tables, you add a S at the end to make it plural, because it's not student, it would be students because it's going to hold multiple students. And then we add our different attributes. So first name, first underscore first name. And this will be a varchar of 255. 255. Don't you just love coding in front of live audience? Okay, 255, and then we're gonna, so PK is primary key. We're gonna not do that. We're not gonna use first name as the primary key, but it is gonna be not null. And then we're gonna add another attribute, so last name. This is also gonna be a varchar of 255. Let's change it up a little bit. Let's make it 50. And then not null. Let's go up here and make this one 50 as well. So typically for like a first name and a last name, we're gonna make the size 50 for something like this, but for something like a email, we're gonna make this 255, since the email can have longer character sets in it. Make this non-null as well. And then we're gonna introduce the date registered. And this is gonna be a date time object. And it's also gonna be not null. And this is our students table. Then we're also gonna go and create another table. Here. And this table is going to be called courses. I hope I spelled that right. Courses. And we're going to have a title, which is going to be a string, so varchar of 255, because the title can be long, not the primary key, not null. And we're also going to have price. Price is going to be a decimal of 5 and 2. And this is going to be not null. The reason price is a decimal of 5 and 2, 5 just meaning 5 decimal place, 5 numbers, and then with 2 characters after the decimal place. So the highest number we can have is 999.99. For a course. And then we're going to have the instructor, which is going to also be varchar of 255. And it's going to be not null. And then we're going to have our tags of the course, and it's going to be a varchar of 255 as well. And not null. So then now we have our two tables. We're going to need to introduce the pivot table that links the two together. So add this table. And this is going to be the enrollments. And then an enrollment is going to have a date of date time. It's not going to be the primary key, not null. And we're also going to have the price. And this is also a decimal of 5.2. And now we need a way to connect the two tables together. So if you look on the left, there is a way to make that connection. Let me bring this down. So here we have one-to-many. So we click on this, and typically the parent, which is a student, will connect with the enrollment. But if you look down here, it says select the foreign key constraint table first. So where would have the foreign key would be here, and then the primary key would be here. But before we do that, let me introduce something else. So let me zoom in a little bit so we could see this a little bit better. Okay. So with students, we're going to need a way to identify that student. Typically, we have a primary key. So we could use first name as that primary key, but primary keys have to be unique. So my brother, his name is Henry. So if we both enrolled as a student, we won't be able to differentiate which one of us enrolled in this platform. We can also use a composite primary key, which is first name and last name together. But then, for my brother, we're both Henry Saint-Juste, so that's not going to work either. We can use the email, which could be unique, but emails typically change, so we want to pick something that's not going to change for a user. And then also you have the limitation of when you create a primary key and that primary key become a foreign key somewhere else, that's going to be duplicated everywhere. So you probably don't want 255 characters being duplicated everywhere on the database. So this is where we're going to introduce a student ID. So here, student ID, and then this is going to be integer, and it's going to be the primary key. It's going to be not null, and we're going to set it to auto increment. So the first student gets enrolled is going to be either 0 or 1, and it's going to auto increment thereafter. And we're going to do the same thing. Let's go ahead and move this up real quick. Student ID, student ID, student ID, move up. Okay, cool. And then we're going to do the same thing for courses. We're going to introduce a course ID. And this is going to be an integer. And the reason why we're choosing an integer is because we've spoken to the stakeholders, and they told us there's going to be a lot of users, but it won't pass 2 billion users in this application. And an integer holds about 2 billion entries, or it can go up to 2 billion. This is going to be the primary key, and it's going to auto increment. So now that we have those two, let me move this up real quick so it can be clear for us. Okay, now we're ready to introduce the pivot table. Oh, okay. Well, it already has it. So let's see. Okay. The pivot table, we're going to, hold on, did I add? Oh, geez, hold on. Let me, delete selected. Course ID, we needed to add it here on student. Primary key, auto increment. Okay, we're not gonna worry about moving it up right now. So then we would want to connect this together. So we would click here for one-to-many relationship. We select the foreign key constraint table first, and then we select the parent table. Come on. Oh, geez. Let's see. Delete. Delete. Okay. Select one too many. Right here. Come on. Select it. And then select it. There it is. And then we're going to do the same thing with the course. Select this. And then select this. And then there we go. And then you can see here we have the student ID and the course ID. So typically they prefix the database versus the table name and the ID together. So you could remove that if you want to. I'll leave it like this for now. And then we also have to add the foreign key constraints. So we select our enrollments table. We go to foreign keys, and you can see you have your foreign key here. So what this does is when you want to delete a student or an enrollment, it lets you know, okay, how should we populate? How should the database react towards that? So on update, we should always cascade, because if let's say the student ID changes, we would want that to be reflected here as well. And then on delete, let's say we want to delete an enrollment or we want to delete a student, what should happen on delete? So you need to talk to the stakeholders to figure out what they want to do. Typically, you do no action or you restrict, which would not allow an enrollment to be deleted. And then if the student information gets deleted, the enrollment stays, just so that way, they want to do, the business may want to do like a forecast of how many courses were sold in this month, or et cetera, or the courses that were popular. So we want to do the same thing here. We want to cascade on an update. And on delete, we want to take no action, or we want to restrict. And this is how you build a physical model. Any questions so far? Awesome. So we talked about normalization. Normalization is the process of reviewing a database design to ensure that it adheres to predefined rules to prevent duplication, and we can refer to the 7 rules of normalization. So the first one is the first normal form, which says that each cell should have a single value, and we cannot have repeated columns. So if we look at our let's go forward. If we look at example, right? So this is a description for a session like this, and it has what the room is going to be in, and it also has the tags. So we have SQL, database, and architecture. So if we were designing this kind of database and the tags were attached to, these tags right here were attached directly to a session, then if we have another session with these same similar tags, that means that's going to be duplicated over to the other session as well. So a great way to put this in first normal form is to introduce another table that only has the tags, the tags and also their IDs, and then we refer to the IDs in the table itself. So we're not actually duplicating this data, and this is how you put this into the first normal form. The second normal form, if we go back to our example, let me go back to our example to see how we could do this as well. So in our example, we have tags. And a tag may be, let's say we have front end for a course and we have back end for a course. And these are comma delimited. So you have back end and then you have, let's say, database. So if this was, if the tags lived on here, then every single time we have a course, we would duplicate these tags. Instead, the smart thing to do would be to introduce yet another table. And that table can be called course tags. Did I change that name? Let's see. Oh, no. Course tags. And then this would hold the actual tags here. Move this out of the way. This would hold the actual tags and would refer, this course would refer to these tags, IDs, instead. The second normal form states that it should not have any non-primary attribute, that it functionally depend on any proper subset of any candidate key of the relation. That's a mouthful. So what does that mean? It just means that each table should describe one entity, and every column that table, and every column in that table should describe that entity. A good example for the second normal form is this. So we have a flight system or a booking system for an airline. Let's say NetJets. We have an order, we have an order date, and we have a passenger. Now see on passenger, we have first name and last name. And that's being duplicated over and over again every time you create a new order. So the best way to adhere to the second normal form is to remove this duplication of data. Because if the user changes their name from John Smith to maybe Albert Smith, now that data is not consistent with previous information. So the best way to do it is you introduce a passenger or a user's table that has John Smith with the ID of 1. And every time John Smith makes an order, you reference to the passenger ID. So if John Smith becomes Albert Smith, that data is, you keep your data integrity. So that's adhering to the second normal form. And the third one is, the third normal form is all attributes in the table are determined only by the candidate's key of that relation and not by non-prime attributes. You know, what does that even mean? This example shows it better. So third normal form, you have an invoice, you have an order ID, a date, a passenger, you have a total and a payment, and then you have a balance. If you can see the total and the payment, the balance is derived from these two fields or attributes. So instead of doing that, since we can derive the balance from these two attributes, we just drop the balance altogether. So then the back end or the front end would calculate the balance based on these two fields instead. And the reason why we would do this, the reason why this is problematic is because if we update the payment, we also have to go through and update the balance. All right, so now let's jump into DynamoDB. So DynamoDB is a NoSQL database. It is serverless, and it has single-digit millisecond performance at scale. It's also secure, and it supports flexible data since it's, unstructured JSON. And when we look at it, just comparing it again, right? SQL, you have where you have tables. On DynamoDB, you have collections. You can have tables too, but typically you have collections. DynamoDB does it a little different than like Mongo. Mongo has collections and documents, but then with DynamoDB, you can also have a table. You have rows, you have items, you have columns, you have attributes, primary key, and then you have a primary key that is mandatory, and then sometimes you can have a sort key as well. You can have a local index. You can have index, and you can have a local index. You have views here, and then on DynamoDB, you have global secondary indexes. So typically, this is the interaction to a database. You have your client or your mobile application, which hits a backend API, maybe a .NET API or a cloud native API, that then hits your database that gives the information to your front end. This is the traditional approach. The non-traditional approach is, did I have that? Okay, cool. So let's say something happens in production. So now the developer has to manually connect to this database to do something with this database to manage it. And this is typically not encouraged. Okay. Any questions so far? Awesome. Let's go on to, let's see. All right. Hopefully you can all see this fine. So DynamoDB. This application is an event application, similar to Eventbrite or a Meetup. So it has different events for users to attend. And we're going to use DynamoDB, and it's going to use the single table design. The single table design, rather than, so there's two approaches to designing in DynamoDB. You can have multiple tables that holds your collections and your data, or you can do the approach of single table design. Single table design is the approach of, can you all see this properly? Yes? Okay. Is the approach of using a single table to hold all of your data and entities. And when you do that, you have key concepts to be able to help you retrieve your data. You have your primary key, your PK. You have your SK, which is your sort key. And then how you would architect your table is using a delimiter of pound. So you have your event, pound, and then the event ID, and then you have your different sort key or different types. And essentially, you're adding your attendee, you're adding your event data, you're adding your messages all in a single table, and you can be able to query for that based on your access pattern. So you can say, okay, I need all of the events for I need an event with this event ID for this metadata, and this gives you the event and all of the information associated with it. If I needed the attendee of that event, I say, okay, for this event, give me attendee sorted by attendee with this attendee ID, and I get the attendee profile. If I wanted to get the messages, I can query for this information to get message 1 or 2. And then you introduce global secondary indexes because you need to be able to query for different access patterns. Let's say you wanted to get all of the events by a particular organizer. Since this is our primary way that we query for the object, this doesn't allow us to do that by organizer. So we add a global secondary index to be able to query our data by the organizer. Awesome. So that's my talk. So if you're interested at NetJets, careers at NetJets, we're hiring. You can reach out to Scott Flowers, which is the manager of software engineering. You can reach out to Ryan Tuttle, director of software engineering, or you can reach out to Megan or Brian, which are our recruiters. And then you can follow me around. Again, my name is Henri Berson Saint-Juste. This is my LinkedIn profile. And if you want to follow me on X, that's the best way to do so. If there are no more questions, that is it.